Good afternoon, everybody. My name is Martti Kukkola, and I'm here to tell about the Oilon ChillHeat industrial heat pumps. I work as a Chief Business Officer responsible for the industrial heat pump business in Oilon. And in this presentation, I will go through one high-temperature heat pump reference case, and then very shortly at the end, we will have a look at a few other award-winning cases. High temperature has been something that Oilon has been aiming all the time, and currently we are there with our products with 120 degrees, enabling more and more applications to be renewed into carbon neutral solution. So it's all about decarbonizing sectors that earlier couldn't have been decarbonized. And with 120 degree, you can do a lot in industry. And what is basically at the moment really rapidly growing market for us is district heating, district cooling sector. So one case example is the Karlsborg factory in South Sweden, where they produce aluminum pigment. Very traditional company that then decided to turn their production to more carbon neutral. In this case, as always with these kind of like pilot cases, it requires a lot of cooperation. Here you see the outcome, so 3 heat pumps installed, actually working in cascade, where at the first stage you have screw compressor heat pump, and then you have the high temperature heat pumps providing up to 120 degree, but they're 110, 105 degree. Refrigerants in the high temperature stage was the ZD, and in the lower stage then ZE. So here's a schema of the installation, and the principal point was that for the aluminum pigment you have the dryers which are working in batch process. So you don't need always all the time the peak capacity. So in the project there was accumulator tanks installed. Then earlier the energy was produced with electric boilers as well as gas boilers. So in this renewal, we got rid of the gas boiler. So there's from the dryer cooling, there's the cold water coming into the cold water tanks, which are cooled down with this kind of evaporating towers. So collecting heat from there with the first stage heat pump producing 380 kilowatt to level about 60 degree. Utilizing that for the real estate heating as well as domestic hot water. You can see there the power, as well as then the high temperature stage using that as a heat source, producing then the required 105, 110 degree hot water. So with the help of these heat pumps, we could reduce the gas consumption. But as said, also in this was important that there was the accumulator tanks to balance the load, and we didn't have to, let's say, dimension the whole system for the peak capacity, but now the heat pump is running much more smoothly throughout the day. So here's actual running data of the case. So every single, let's say, line here represents 1 day. So we are there roughly in 5 megawatt hours per day when it comes to the heat output. This is from this year, February to March. And here's the heating power produced. and then the cooling power produced. So it's perfect like combination of combining cooling and heating. Here we see the output temperature. So 105 degrees has been set there. And then we can see here the evaporator temperature inlet. So this is for the high temperature stage, and this is for the lower temperature stage where we can see a lot of fluctuation in the water tank temperatures. So roughly they're 30 to 20 degrees. Here we can see the, let's say, KPIs for the heat pump installation. So heat produced 131 megawatt hours during this time frame. Cold energy produced 91. Electricity consumed 42, which results in the total COP of 5.3. So with 1 unit of electricity, 5.3 units of useful utilities. So what's of the essence nowadays is that once heat pumps are becoming, let's say, the primary energy source, they need to be reliable. They are not only for energy efficiency, and then you have backup systems, but that's where we have put a lot of effort to secure the highest availability. This is for that time period, same roughly a month, and there was once time when the system was not available, but that was due to the high evaporator temperature. So the water from the cooling, dryer cooling, had increased the temperature higher than 50 degrees, and then we couldn't run the lower stage heat pump. 50 degrees was the limit. So as also in the European Heat Pump Association forum was mentioned just 2 weeks ago, that all these kind of integrations with heat pumps, it's a cooperation between different parties. So you need to know your end customer, you need to have a skilled contractor, and then of course capable products. And in this project to Karlsborg, it was a cooperation with the end customer, Karlsborg, AFRY, and skilled contractor Frank's Tool Industry. And satisfied, it's not only about the savings, monetary savings, but it's also about the carbon neutrality actions, CO2 savings. However, 120 is enough for many applications. So heat pumps are fit for high temperature industrial applications already. But I would say that personally, I think there is still one step to go further, up to 140, 150 degrees. Actually, with that same technology what we had there, we have been producing in our lab 140 degrees already. So that's also one of our aims, to really still expand a little bit the temperature range. But that was a one case I had there. And other cases then, what I wanted to mention, we have a Windham case in Sao Paulo. We have Marcus here today from Brazil, who knows this case better than his own pockets there at our stand. So in this case, there was a traditional chillers and then gas boiler. So in the project, the heat pump was installed to provide the cooling and then utilize the heat in heating, and this way replacing the gas boiler. Very smart solution that then got last year also the award there. Another case from residential sector, this Postipuisto. 2 weeks ago, we received the Decarb Building Award from the European Heat Pump Association. And in this real estate case, heat pump is utilizing ground source. Then the heat pump is providing cooling for the building. Then utilizing waste heat from the supermarket, as well as recovering heat directly from the sewage water. So 4 different heat sources. Then with that energy, heat pump is providing the building heating, domestic hot water, and the surplus energy goes into the district heating network. So we really have designed a system where we don't want to waste even a joule of energy. So high temperature heat pumps are not only for industry, they are for buildings as well, when you integrate buildings, data centers into district heating network. And yeah, this is nice case. Of course, here as well requires good cooperation between the parties, but only in Helsinki there's roughly 30 different integrations already done within few years' time. That's all for my part. We have a stand in this hall, so we can have a more discussion over there about the possibilities, and want to really invite and encourage for actions towards carbon neutrality. Thank you. Yeah, works. And I think there is some time for questions before the next one. So, anybody? Yeah. That was the ZD. Yeah. ZD, yeah. With the ZE, we can go up to 100, and with the ZD, 120. And that's the piston compressor heat pump. Yeah. But I have to say that, yeah, like I said, the next step will be then the steam production. Yeah. Yeah.
On the low stage heating,
yeah.
is that always a water source, or can you also do air source?
Yeah, okay, so lower stage, can it be water source or air source? We Oilon, we have only liquid to liquid heat pumps, but we've done also with other suppliers technology, the lower stage, and then combine that with the high temperature heat pumps, which has resulted into a solution that can create from -10-degree outdoor air, 98-degree district heating. So with this 2-stage system, you can do it, no problem. Of course, then when we talk about COP, so 10 years ago, 4 to 6 was required within industry. Nowadays, some customers come to us and say, is 2 possible? So it has changed a lot. With this kind of like a -10-degree outdoor air, and then producing 80-degree hot water, could be about 2 COP, yeah.
And how do you cope with the defrost cycle?
Defrost cycle. Basically over designing the lower stage coils, so that one or several can be in defrost, while the other ones are utilized. For the defrost, you have electric, or you have some liquid there circulating. Yeah. hot gas and oils. You,
For the defrost, hot gas.
oh, right.
So you're producing very hot water,
Yeah,
or the refrigerant part, and using that back in at your lower stage for your defrost.
in this 1 megawatt air to district heating system, we used hot liquid. But I'm sure there's suppliers who have and use hot gas for defrost. But especially in Finland, you have very cold climate. Our dimensioning temperature is about -26, -29. So there's a lot you need to take into consideration. Okay. Thank you and have a great exhibition.